Hello, this is Jennifer Dassinger with A Plus College Ready, and I'm ready to go over with you the Unit 7 practice problems for general and solubility equilibrium. So let's get started. Multiple choice questions. Choose the best answer for each of the following questions. The number 1, barium sulfate is least soluble in a 0.01 molar solution of which of the following? So at this time, reread the question, look at the choices, pause the video, and we'll be right back with the answer. Well, how did you do? The answer is A. So this is a common ion effect, a question. So think in terms of equilibrium. Barium sulfate solid is going to break down into barium ions, cations, and sulfate ions. So adding more ions is going to shift the equilibrium to the left to make barium sulfate less soluble. So aluminum sulfate releases 3 sulfate ions in solution, which is 3 times more sulfate than salts release. So if you notice, this was a question back in 1994. It was number 65. Only 21% got it correct. So compare and contrast how you did. Question number 2. Which of the following occurs when excess concentrated ammonia is mixed thoroughly with 0.1 molar copper 2 nitrate? So we have our balanced reaction here of copper 2 nitrate, light blue on the reactant side, forming this copper ammonia complex ion, which is a deep blue. So read the question again, look at your choices, see which one will best answer the question, and we'll be right back with the answer. Well, the answer is C. The color of the solution turns from a light blue to a dark blue. So I'm not sure if you've seen this chemical reaction before, but here goes. You have a copper ion that plus 4 ammonias is going to make this tetraamine copper 2 complex. So it's going to cause the equilibrium to shift to form this copper amine complex. So if it goes from the light blue to the dark blue, it's a little bit of Le Chatelier's principle here. Well, let's look at number 3. So number 3 has hydrogen plus iodine gas yields 2 hydroiodic acid, or gas in this case. And notice delta H is greater than 0. So think about the question. Which of the following changes to the equilibrium system represented above will increase the quantity of hydrogen iodide in the equilibrium mixture? So think about it, look at the choices, pause the video, and check your answer. So the best answer is letter C, Roman numeral 1 and 2 only. So 1 is true because if you add hydrogen gas, it'll cause the shift of the equilibrium, favoring the products, increasing hydrogen iodide. 2 is also, Roman numeral 2 is true because if you increase the temperature, and remember, this is an endothermic reaction, it's going to cause the shift of the reaction favoring the products as well. 3, Roman numeral 3 is false because if you decrease the pressure, there's little or no effect to the equilibrium since there's 2 moles of gas on each side. Well, let's check on to our number 4. So number 4 has this 2x plus y yields 3z. The reaction mixture represented above is at 298 Kelvin. Then we have some molar concentrations of y and z and x. X, y, and z, of course. So what is the value of the equilibrium constant for the reaction at 298 Kelvin? Well, pause the video, work it out, come back for the answer. So the answer is C. You just have to expect easy math. First, you had to set up your equilibrium expression with your products of your reactants raised to their coefficient, plug in the values, and then solve. So this is going to take you a few minutes to find the answer, but it's very doable. And notice 69% answer correctly in 2008. See you on number 5. So in number 5, you're given a reaction again, and they want you this time to write the proper K expression. Pause the video and check your answer. So our correct answer, of course, is letter D, because our product of the HI is raised to the second power, and our 2 reactants are in concentration on the bottom. Number 6, which of the following statements about the equilibrium is false? So read your choices. A, if the system is heated, the right side is favored. B, removing HI as it forms, forcing the equilibrium to the right. C, if the pressure on the system is increased by changing the volume, the left side is favored. And D, adding more H2 gas increases the equilibrium constant. So check your answer in just a minute. So the only one that was false was letter D. The rest, A, B, C, were correct. Good job. Number 7, indicate the mass action expression for the following reaction. 2x plus y yields 3w plus v. So pause the video after you're ready and check your answer. And of course, the answer is letter B, products raised to their coefficients over the reactants raised to their coefficients. Pretty much the definition of what an equilibrium expression is. See on number 8. For which of the following equilibrium systems represented below will the amount of products at equilibrium increase if the volume of the reaction vessel is increased at a constant temperature? So compare and contrast your choices of A through D and pause the video and check your answer in just a minute. The answer is A. If you increase the volume, then you decrease the pressure. Therefore, the side with more moles of products will be favored. And since A is the only one that had 1 mole of reactant to 2 moles of product, it was the correct answer. Number 9, our H2 gas is reacting with our iodine gas, yielding that 2 hydrogen iodide gas. Equal molar samples of these 3 gases of hydrogen, iodine, and hydroiodic gas are introduced into a 3-liter container that is heated to 600 degrees Celsius. According to the information above, which of the following will occur as the system approaches equilibrium? So look at your multiple choice choices, pause the video, think about it, and check your answer on this one. So the answer is letter C. More HI will be produced because Q is less than K. The term that you need to recognize is introduced. So that tells you the system is not at equilibrium. You could have plugged in some values, assuming that the 3 liters for every 1 mole, and plugged in and solved for Q. And that would still give you the ability to solve and find that Q is less than K. That's a pretty large K amount. Pause the video and go back on to number 10. So we have 3 oxygen gases producing 2 ozone gases. For the system represented above, we have the oxygen and the ozone initially at 0.150 molar liter and 2.5 moles per liter respectively. Which of the following best predicts what will occur at the system approaches equilibrium at 570 Kelvin? Notice they give you a K value of 1.8 to the power of negative 56 and a temperature of 570 degrees Kelvin. So study those answer choices, pause the video, come back when you're ready for the response. My correct answer for number 10 is letter D. The amount of ozone will decrease because Q is greater than K. So the reason that you need to recognize something is the term initial. Notice it's not at equilibrium. So you're given Q values to solve for, and you're given a K value to compare to. So this is one where I'd plug in a little numbers, check to see what happens. Now without a calculator, if I can still square 2.5 to get 6.25, and then kind of roughly notice that 0.150 is going to be roughly 0.0030, then I can see that I'm going to have a very large Q. Notice my K value is very small. So that kind of gives you a quick just check without a calculator on this one. It's going to take you some time to answer it, but you can do it. Number 11, carbon monoxide plus water gas yields carbon dioxide and hydrogen gas. We're given a Kc value of 1.5 to the power of 3. It says a 2 mole sample of carbon monoxide gas and a 2 mole sample of water are introduced into a previously evacuated 100-liter rigid container. And the temperature is held constant as the reaction represented above reaches equilibrium. So it wants to know which of the following is true at equilibrium. So think about this, pause the video, do a little math, come back and check your answer. Letter C is the correct answer. I recognize that this again is not at equilibrium because of the word introduced. And the reason why the carbon dioxide is going to be greater than the carbon monoxide is that if I plug some numbers into a Q value for my reaction quotient, I'm going to see that that is going to be pretty small comparatively. And I recognize that I have a pretty large K. So therefore, my Q is going to have to be less than K. The system's not at equilibrium. The reactants, of course, are going to form more products until the Q is equal to K and K is greater than 1. See you on number 12. So now on number 12, we had an endothermic reaction because delta H is greater than 0. And then I noticed that I have this cobalt peroxide complex with this chlorine yielding this cobalt complex that is blue and some water. If you haven't done this reaction, the nickname is called the Pink Panther. When cobalt 2 chloride is added to pure water, the cobalt ions get hydrated. And those hydrated form and then react with the chlorine ions to set up an equilibrium. So number 12 wants to know which statement below describes the change that the system will undergo if water is added. So read the choices, pause the video, come back to check your answer. So think about Le Chatelier's principle. The answer is letter A. If you add more water, then you're going to increase the product concentration, which will cause the reaction to shift to the reactant side to relieve that stress. So therefore, it's going to make more chloride ions. So we're in the land of Le Chatelier. If you need some more time to review Le Chatelier, check out the PowerPoint. We'll see you back on number 13, which is also with our Pink Panther. So number 13 is still on our Pink Panther problem that we have here, but notice the question this time. Which statement below describes the change that the system will undergo if silver nitrate is added? So think about what will happen in the shift when silver nitrate is added. Pause the video, come back for a response. So the correct answer is letter B. Again, we're in the land of Le Chatelier. If you add silver nitrate, then the reaction is going to become more pink because it's going to remove the chloride ions due to the formation of silver chloride, thus causing the equilibrium to shift toward that production of that pink complex to restore the consumed chloride ions. So there you have it. On to number 14, still with our Pink Panther problem. Back to Pink Panther on number 14. Which statement below describes the change the system will undergo if 6 molar hydrochloric acid is added? So read the answer choices, think about which way the reaction is going to shift and why. Come back for a correct response. The correct answer for number 14 is D. We're still in the land of Le Chatelier's principle. Finding a trend here. If hydrochloric acid is added, remember it's concentrated, then the reaction becomes more blue because you're going to be forming more of that cobalt chloride complex ion. Therefore, it's going to shift to the product side in order to consume that extra reactant, which means, you guessed it, more product. So more problems to come with the Chatelier and the Pink Panther. Stay tuned. Da-dun, 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 da-da. Number 15. What would happen to the system if oxygen were added to it? Well, look at those answer choices of A through D. Pause the video, come back for a correct response. Well, the answer to number 15 is B. Oxygen would have no effect on the equilibrium of the reaction. And you're like, what's going on? Well, in Le Chatelier's principle, if you're adding a gas that is not involved in the reaction, it doesn't affect the equilibrium. Plain and simple. Pause the video, come back for number 16. Last question of our Pink Panther problem. What would happen to the system if this temperature were decreased by placing the reaction in an ice bath? So think about it, look at your choices, pause the video, come back for a correct response. The correct answer for number 16 is letter A. If the temperature was decreased, then the reaction will shift to the left because that reaction is endothermic and the amount of heat is on the reactant side. Okay, we're back with Unit 7, practice problems for general equilibrium and solubility equilibrium. On number 17, for a certain reaction at 25 degrees Celsius, the value of K is 1.2 to the power of negative 3. At 50 degrees Celsius, the value of K is 3.4 to the power of negative 1. This means that the reaction is, we'll think about it, and we'll come back. Yes, that's right. The answer is B. It has to be endothermic. So Le Chatelier's principle is where endothermic reactions or energy are kind of like reactants. So as the temperature increases, this predicts that the reactants will decrease while the products will increase. Therefore, this will increase the value of K. Notice the temperature increase. There you go. Come back for number 18. So for number 18, ammonia is prepared industrially by this reaction called the Haber process, where you take nitrogen gas plus 3 hydrogen gas to make 2 ammonia gas molecules. So for this reaction, the delta H is negative. It's 92.2 kilojoules at a K of 4.0 to the power of 8. Notice that's at 25 degrees Celsius. When the temperature of this reaction is increased, though, to 500 degrees Celsius, which of the following is going to be true? So think about number 17. I'm sure you'll figure out number 18. Pause the video, check your response in just a minute. So that's right. If you knew 17 was endothermic, 18 has to be exothermic, for our delta H is negative. So the answer is C. Due to Le Chatelier's principle, the temperature of the reaction is going to increase, then the reaction was going to shift to the left. In other words, the concentration of your reactants will increase while the product concentrations will decrease. This, in turn, it means that the value of K will decrease overall. Problems? Hope not. Hope you're able to figure this one out. See you for number 19. So questions number 19 through 22 are going to refer to the following system. X gas is going to react with a hydrogen, 2 molecules of hydrogen gas to release this 2 hydrogen gas complex and energy as a product. 19. Addition to the X component to the system describes by the above equilibrium. So what's going to happen when I add that X2 to this problem? Let's see. I feel like you're an old hat at Le Chatelier's principle by now. So obviously the answer is A. When you add a reactant that causes the equilibrium to shift to relieve the stress, this is, of course, causing more product to form. Hope you understand. Let's look at number 20. So we're still in the same reaction complex, but on number 20, they want to know what's going to happen when you add argon to the above equilibrium. I think we've seen a problem like this before, but pause the video. Hopefully you'll check your answer and be able to get it correct this time. Of course you got the answer correct. The answer, of course, is letter D, has no effect. Because again, we remember from our previous question that Le Chatelier's principle, if you have the addition of inert gas, a solid, or a pure liquid, it has no effect on the equilibrium concentration and will not be included in that equilibrium expression if ever asked to write one. I knew you got it right. So let's check number 21 and 22 with this complex. In 21, it's asking if you increase the pressure by decreasing the volume, what will cause the reaction to do? What's going to occur? So pause the video, read the responses of A through D, come back and check your answer. Of course, if you increase the pressure, you decrease the volume. This is, of course, in Le Chatelier's principle, equilibrium will favor the side with the least amount of moles. So the reaction is going to produce more of this H2X complex due to that there are more moles on the reactant side. Therefore, the shift is going to be to the products, making more of the product being formed to relieve that stress. We'll see you one more time on question number 22 with this complex. Last question in this series is number 22. So it's asking if you increase the temperature, it will cause what to occur in the reaction. Pay attention to the reaction. Notice where that energy is written. Pause the video, come back for the correct response. That's right. In number 22, the reaction is exothermic. So remember, in Le Chatelier's principle, letter B, the reaction is going to produce more of the reactants, the hydrogen gas and this X gas, because if you increase the temperature of the exothermic reaction, it's going to shift to the reactants to relieve that stress. Hope you got a lot of Le Chatelier's principle help and you were able to get the concepts down pat. If not, I'm sure your teacher will have more practice for you. Now that we're out of the land of Le Chatelier, let's look at number 23. Given the equilibrium constants for the following reactions, so you're given the first K of the first reaction and a K2 of a second reaction. Then it wants to know what is the K for the overall system of 2 copper solids plus oxygen gas yielding 2 copper oxide solids going to be equivalent to. So what's going to happen with that K1 and K2? Look at the reactions, compare and contrast. Pause the video. This will take you just a minute, I hope. So for 23, the correct answer is letter C. So if you look at the K1 reaction, the coefficient of copper is 4 versus 2 in the final. Therefore, the K1 needs to be reduced by half, and the K2 reaction is the reverse of the final. So then you're going to have to take the reciprocal of that K. So it'll be 1 over K. So therefore, letter C best represents what is going on in the multiple series steps of reactions to get to that final reaction. Hope you're able to figure this out. If not, go back and look at the questions that I have in practice for you in the general equilibrium basics of calculations. Number 24, I'm feeling a little nostalgic. So I thought we'd throw back in a little bit of electrochemistry at you. So you're given this electrochemistry reaction of copper solid with silver ions reacting and forming copper 2 ions and silver solid. It says the equilibrium constant for this reaction is 3.7 to the power of 15. Which of the following correctly describes the standard voltage of the E cell at the standard free energy change of delta G for this reaction? So think thermodynamically favored. Pause the video, come back and check your answer. Number 24 is just a reminder that even back in electrochemistry, we were talking about equilibrium. So for a thermodynamically favored large K or K greater than 1, we have to have a positive voltage. Therefore, we see the not symbol, the little 0. That means we're at standard conditions. So for a thermodynamically favored galvanic or voltaic cell, we remember that our delta G is negative, our E cell is positive, and K is greater than 1. So my phrase is, get me to the geek. Get it? G-E-K. Get me to the geek. See you next time for number 25. Just when you thought we wouldn't get to it, we're now in the land of KSP, aka Solubility Equilibrium. So number 25 is asking how many moles of sodium fluoride must be dissolved into a 1 liter of a saturated solution of lead-2 fluoride at 25 degrees Celsius to reduce the lead ions to a 1 to the power of negative 6 molar concentration. The KSP for lead-2 fluoride at 25 degrees Celsius is 4.0 to the power of negative 8. So pause the video. You're going to have to do some quick mental math and some quick jotting down to figure this one out. Might take you even 2 minutes. So right out of the gate, I threw a hard one at you. The correct answer is letter C, and let's talk why. You're going to have to calculate that fluorine ion concentration. They give you the lead ion concentration in the KSP. So you plug in your lead ion concentration. You have to, of course, raise the coefficient of the fluorine ions to 2. Therefore, that means you're going to take the you're going to combine like terms, solve for fluorine ion, and then that's going to give you x squared of 0.04. But sodium fluoride has only one fluorine, so therefore you're going to have to take the square root of that. So just kind of think you're going to half it again, if you will. This one was a really hard one. It says the amount of fluorine already present in solution is negligible since the KSP is so small to begin with. You might want to look at that KSP value next time. Well, hopefully you won't quit on me now. Stay tuned for more. Number 26 is asking the solubility of copper iodide. Copper 1 iodide is 2 to the power of -6 molar. What is the KSP, or solubility product constant, for copper iodide? This is hopefully a little bit easier in 25. Pause the video, do a little jotting math, mental math, come back for the answer. So 26 is a lot easier. It's classified as a medium problem. So if you recognize that the molar solubility was 2 to the power of -6, and that the copper to ion concentration is a 1-to-1, therefore I can just substitute that for my x, but take the square of those, and when I square 2, of course I get 4, and square my -6, and I'm going to get 12. Hopefully you got that one right. Compare to yourself to 1989 and see how you did. 27 is asking what is the molar solubility in water of silver chromate. The KSP for silver chromate is 8 to the power of -12. So pause the video, set up the problem, come back for the correct response. 27 is still classified as a hard problem, but the correct answer is D. It's really asking for the correct setup. That's the good news. So you had to recognize that there were 2 silver ions for every 1 chromate ion. So remember, you take that coefficient, 2x is raised to the power of the coefficient of 2 and times x. And remember that combined like terms, that's going to be 4x cubed. And that is going to be equal to your KSP value of the 8 to the power of -12. Then you're going to, of course, take the cube root, but first divide 8 by 4. That's going to give you, of course, 2. And then x is going to be the cube root of 2 to the power of 12. Since the answer is not up there, that's the best setup, and hopefully you're able to figure that out. Still challenging, but you can do it. So number 28 is giving you hydrogen gas plus bromine gas yields hydrobromic gas, okay? Not acid, but 2 coefficient of bromide gas, At a certain temperature, the value of the equilibrium constant K for the reaction represented above is 2 to the power of 5. What is the value of K for the reverse reaction at the same temperature? So think reverse, think of previous problems, pause the video, come back for the correct response. So the correct answer is letter B. So let's don't forget that for an equilibrium expression, products over reactants. So if I flip it, I take the reciprocal of my K value for the reverse. It's 1/2 of 2 to the power of 5. So that's going to give me 0.5 to the power of 5. Well, there's no 0.5, so I know it can't be D. I know it can't be C. I know it's not going to be A. Therefore, I knew I had to move the decimal over 1 to get to the power of -6. It's really not bad once you break it down and look at it. Hope you did okay. We'll come back for the last few, 29 and 30. So number 29, in a saturated solution of zinc 2 hydroxide at 25 degrees Celsius, the value of the hydroxide ion is 2.0 to the power of -6 molarity. It's asking for what is the value of the solubility product constant, KSP, at 25 degrees Celsius. So you're going to need to pause the video, set up some math, do some mental math, come back for the correct answer. So 29, the correct answer is A. So write your equilibrium expression. Notice that they give you the hydroxide, and zinc will be half of that. So take the half, and that's going to be 1 to the power of -6. Therefore, I plug it in, my values. Now think mental math. 2 squared is 4. Then my exponent of 6 will be squared, and that'll be 12. 12 plus the -6 from my zinc, and that's my 18. There you have it, ladies and gentlemen. So number 30 is giving you this other complex. I want you to pause the video, read it, and check your